Do you feel the vibes?
Start here. Oh, hello. Welcome back. Okay. What class was the other one? Oh, yeah. Yeah. Graphing sine and cosine functions, right? You have no idea how excited this makes me. I mean, like, I have trouble sleeping the night before I have to teach this because of how exciting it just is, right? So let's do this. Okay, so we did a little bit of graphing yesterday with the sine and the cosine functions. You can sit here, by the way, if it helps you see better. Okay. So this is an example of a sine function in, more of its glory than we saw yesterday. You see, a bigger chunk of it. What you should first notice is that the curve is continuous. There are no breaks. There are no gaps, right? So that means the domain of this sine function is always all real numbers. All real numbers. It is just continuous from infinity to infinity, right? Now, the range, this is what we talked about yesterday, is it goes to a maximum of 1 and a minimum of -1 at all the points here, right? So the range is always going to be -1 to 1 for the y's. This is important. Okay. Now, for a sine function, another important piece is there is a y-intercept 0, 0. So when x equals 0, when the angle is 0, the sine function is 0. So it starts on the axis at x equals 0, right? At x equals 0, it is on the axis. Now, let's talk about this term, amplitude. Amplitude is the distance from the axis to the maximum or the axis to a minimum. And the amplitude is always going to be 1. Now, we're just talking about the parent function. Okay, so the amplitude is going to be 1. Okay. Lastly, let's talk about this term. So let's trace out, like we did, one cycle of it. Do you see how like there are repetitions here? Let's trace out one cycle. So I start here, I go up. Let me actually do it in red. So I start here, I go up, I go down and back up. And this right here is one cycle of the sine function. All right. And then after that, it repeats. So how long did it take for the wave to complete one cycle? Well, we started at an angle of 0 and we ended at an angle of 2 pi. So the length that it took to complete one cycle is the period, right? So the period is 2 pi. That's exactly what we saw yesterday, right? We graphed one cycle. We went from 0 to 2 pi. So it took a length of 2 pi for this to complete one cycle. Okay, that's for sine. Now let's take a look at cosine. At first glance, especially when I take away the y-axis, there isn't really much difference in the way they look, correct? Actually, if this sine function was like movable and if I held on to it and I just nudged it over just by a little bit, this part would align with the axis and would look like a cosine function, right? So they're very, very similar to each other. The domain is all reals again. The range is again from -1 to 1. Here is the important part. The y-intercept for the cosine is 0 and 1. So here's the main difference that you have to remember. When x is 0, sine starts on the axis, cosine starts away from the axis. All right? The amplitude is still 1, and one cycle starts at 0, completes at 2 pi, so the period is also 2 pi for the cosine. Okay? So, as I mentioned, the graph of the cosine is just a horizontal translation of a sine graph. If you take the sine graph and just move it over, it'll become a cosine graph. Now, the sine and the cosine graphs repeat after every 2 pi. After the same period, they repeat. That's why they are called periodic functions. Why is the periodic table called the periodic table? Because all of the properties of the elements repeat after like the first 8 elements. You get an alkali again, and then an alkaline earth, and then you get, right? And then up to the noble gases, and then it starts again. So it's the same thing, okay? All right, and any transformation of a sine function is called a sinusoid. So both of these, like together, these are called sinusoidal graphs, all of these graphs. Okay, so here we go. Standard form of sine and cosine, or general form rather. So here we go. This is it in all its glory. Y equals a sine bx minus c plus d. Okay, so x and y are the variables. The rest of these, right, the a, the b, the c, the d, all of these are constants that have a purpose in this function, just like we saw in like parabolas, right? Like plus h, minus k, this, that, okay? So, and here we go. Each of these, like the a, the b, the c, the d, are responsible for showing us the amplitude or the period or all that, okay? More on this later. So we're going to break each of these into separate parts. Let's take the first one. Amplitude, right? The distance between the axis to the max or the min. Amplitude is the absolute value of A. So amplitude is a distance. You can never have a distance of -3, can you? You can also never have an amplitude of -3. It's 3. Okay, so let's talk about amplitude. If the absolute value of A is greater than 1, we have a vertical stretch, right? It's just pulled upward and downward, and so the maximum gets higher, the minimum gets lower, okay? If it's less than 1, there is a vertical compression, okay? The wave just gets smaller. If A is negative, there is a reflection. Is there anything new here? No. Okay, that's why in the beginning, in the very beginning, when we do this, in chapter whatever, 3 or 4, with the parabolas, with the quadratic functions, I am so particular and specific because we're going to use it every single chapter until chapter 12, right? So it makes my job easier if we are like, if we get it in the beginning. Okay, so here we go. What is the amplitude of this function? It's f of x equals 2 sine x. 2. Amplitude is 2. Okay, so now what we're going to do is we're going to graph this, okay? So here we have x, and here we have f of x. So, okay, before I put that, when you're going to graph a function, all right, a sine or a cosine function, you are going to have 5 points to your graph, always. These are called the 5 critical points. Now, what is the period of the sine function? 0 to 2 pi. The period is 2 pi. So we go from 0 to 2 pi. And now you break that into halves. So the half point is a pi. And then the 2 midpoints here are pi over 2, 3 pi over 2. Is that right? How many points is that? That's 5 points. So 0, pi over 2, pi, 3 pi over 2, 2 pi. You're always going to have 5 points on one cycle. Okay, let's plug these in. So 2 sine 0. What's sine of 0? 0, so that's just 0. 2 sine pi over 2. What's sine at pi over 2? 1. So this is going to be 2. Okay, at pi right here, what's sine? 0. So this is 0. 3 pi over 2, sine is the vertical one. It's -1. So this is -2. 2 pi, sine is 0. So this is 0. So here we go. We go from 0 to 2 to 0 to -2 to 2. And when you graph, oh my God, how beautiful is that? And so periodic function means it repeats. So look, I go from axis to maximum, axis, minimum, axis. So let's do it again. Axis, maximum, axis, minimum, boom. That's how quick it really should be. You see that? Oh my God, look at how beautiful that is though. Look at that, right? Come on. Come on. Thank you. Oh my gosh, like I'm just like, every year I'm like, hello sine function, right? It's like an old friend that I haven't seen in like several months and you're like, oh my God, I missed you. Okay, so let's do -1/2 cosine x. What's the amplitude? Ooh, 1/2. Thank you. Always positive. Good. Okay, so we're going to go from 0 to 2 pi. So let's see, x and f of x. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay. Okay. So here we go. You shouldn't have to draw this every single time. What I like to do is I'm like, okay, 0 is over here, right? The cosine is +1 there. So how much would it be here? So it's -1/2 cosine of 0. Cosine of 0 is 1. This is -1/2. Okay? Huh? There's a negative in the function itself, right? So at pi over 2, cosine is 0. So this is 0. At pi, cosine is -1. So this is -1/2 times -1, 1. 3 pi over 2, cosine is 0. Half. And then at 2 pi, it's -1/2 again. So here we go. -1/2, 0, half, 0, -1/2. Do you see that? And then let's continue. We go back to 0, half, 0, -1/2. And when you graph, okay, there we go. Okay, so do you see when x was 0, sine started on the horizontal axis? When x was 0, cosine started away from the horizontal axis. Okay, fabulous. Okay, so that's how we deal with amplitude. And do you also see how here the amplitude was 1/2? So it's literally like a shorter wave. Yeah? Okay. If you're musically inclined, you know, this would be like turning the volume down. Okay? All right. So the period. The period of a function is a formula which you absolutely must memorize. You notice throughout this chapter, there are lots of times where I say, don't let me catch you memorizing this, right? But this one, you have to memorize this. I mean, it's just embarrassing to go around not knowing this, right? I mean, you'll never be invited to any of the math parties. So memorize this, okay? I mean, it's often like the password to get in, right? They're like, hey, what's the formula for the period? And you're like 2 pi over b. You're like, okay, you can go in. Okay? Okay? All right. So when the period is modified, remember how we said it takes a length of 2 pi to complete the wave? Now imagine you're like, okay, go faster. Make sure you finish in the length of a pi. Now you have a different looking wave. Okay? So when the period is modified, what we do is we take the term bx plus c and solve the inequality with bounds equal to the period. So for example, for sine and cosine, the equation will be this, or the inequality will be this. Because when you make the wave faster or longer, you might end at a different place. You have to have a way to figure out what that different place is. And when you do this that I just highlighted, once you solve for x, it'll give you a new start and end to one period of your function. So take a look at this. Here we have cosine half x. When you have a function, when you have a half in front of the x, when you have a coefficient of the x, it's now going to take either less time or more time to complete the wave. So the period is 2 pi over b. This number, the coefficient of x is b. So this is going to be 2 pi over a half, which is 4 pi. The period now is 4 pi. That means it's going to take all the way to 4 pi to start again. Okay, so here's what you do. Oh my God, I love these. Okay, so you go 0, less than or equal to, and then less than or equal to 2 pi. Why? Because the default sine and cosine always go from 0 to 2 pi. In here, you put the entire bx plus c, however much of it there is. Right now, all I have is a half x. Cool? Cool. Now, gotta solve for x, multiply by 2 everywhere. So I have 0, x, 4 pi. This tells you the start and the end of the new function. Okay, so here we go. 0, 1, 2, 3, 4, and I put 4 pi. You have to have 5 of these points. Okay, split it in the middle. What's the halfway point? 2 pi, and then here, pi, 3 pi. Okay, listen. You know how we made these charts? None of the cool people make this chart, okay? We usually just put the points because we know it's going to oscillate back and forth. All you need to remember is, are you graphing sine or cosine? Do you start on the axis or away from the axis? So this is a cosine. On the axis or away from the axis? Away from the axis. What's the amplitude? Not a half. It's a 1. The amplitude is a 1. It's the all the way 1 cosine, right? So is it positive or negative 1? There's no reflection, so it's positive 1. So here we go. This is 1. This is negative 1. Now watch. Watch how I do this. Maximum, 0. Minimum, 0. Maximum. That's all. And now you got to connect. Make it cute. Oh, see, that wasn't even, but that's okay. Okay. All right. That's all. So the normal one, don't draw this, but the normal one would have finished by 2 pi. It would have looked like that. Okay. Do you see how now it took much, much, much longer? So again, who here like sings or plays a musical instrument? Couple of you. Okay. So this would be the difference, let's say, between like a middle C, right? And then like an octave lower, right? Now, right? A lower frequency. All right? Okay. So let's do another one quickly. Okay, so what's the period here? Not 3. 2 pi over 3. Okay, so now we're going to go 0 to 2 pi. Inside, what are we going to put? The 3x. So now I get 0, x, 2 pi over 3. So I start at 0, 1, 2, 3, 4, 2 pi over 3. Okay. You always have to go half point, right? What's the half point from 0 to 2 pi over 3? What's the midpoint? Pi over 3. So basically what you do is the midpoint, look over here. The midpoint between 0 and 2 pi over 3, it's basically the halfway point between 0 and 2 pi over 3, right? So that's just pi over 3. Here, you divide, by half again, so it's pi over 6. Now, this one here in the blue, okay? This is halfway. You see how I write it? It's halfway between pi over 3 and 2 pi over 3. Some people look at this and they're like, oh my God, Miss Milliken, I know what it is. Okay, I was never one of those people. So I had to write it down. Fine, it's okay, right? Remember in geometry, we told you what midpoint was. What was midpoint? X1 plus X2 divided by 2. So X1 plus X2 divided by 2, because it's halfway between this and this. So this is half of 3 pi over 3, which is just what? Pi over 2. This, I would say, is the most hard, difficult part, right? And then, so the amplitude here is 1 and 1, is 1. So I'm going to go from 1 to negative 1. This is a sign on the axis or away from the axis? On the axis. So I go here. And then, because it's positive, there's no reflection. I go maximum, 0, minimum, 0, and there. Do you see that? It's black magic. It'll always work out that way. If it didn't, nothing would work the way it does. Okay? All right. Okay. Okay, I'm actually going to skip phase shift. Okay? We're going to go to vertical shift. Okay. Vertical shift, you know what it is. The D, the constant D is what's responsible for vertical shift. And it's really like when you had K, right? So if you have plus 2, you go up 2. If you have minus 3, you go down 3. That's what it is. Now, just like when we were dealing with remember asymptotes and everything, and if there was a vertical shift, everything moved, including the asymptote. So if there is a vertical shift, the axis of oscillation moves, everything moves along with it. So, when you have a vertical shift, the line y equals d becomes the new horizontal axis, right? There is a new axis of oscillation. This is called a midline. I like to use the word axis of oscillation. It really, whatever. This is not a deal breaker. Okay, so sine of x minus 2. What's the amplitude? 1. Is there a change to the period? There is no change to the period because the coefficient of x is still 1. Now, this negative 2 here is your d, and it gives you the vertical shift. So the vertical shift is down 2. So let's go down here, negative 1, negative 2. At negative 2, we have our new axis of oscillation. Let me make it more straight because, Okay, so the amplitude, the period hasn't changed. So we're going to go from 0 to 2 pi. So 1, 2, 3, 4 to 2 pi. So I got pi over 2, 3 pi over 2. Okay, the amplitude is 1, correct? So this is negative 2, this is negative 3. Now, what are we graphing, sine or cosine? Sine. Okay, look, does sine start on the axis or away from the axis? On the axis. Where is the axis? It's that new purple line. So take a look. On the axis. Then up 1 on the axis. Down 1 on the axis. Do you see that? It's exactly the same way. Ignore the old axis. So now it's like, okay, here, maximum 0, minimum 0. Same exact thing. You can literally do it with your eyes closed. There we go. Okay? All right. Let's do this one. Oh my God, so many beautiful functions here. Okay, let's do this one. Okay, you know what? I'm going to be a rebel. And I'm going to change this function because we didn't do one with a vertical, with a reflection. So why don't we make this negative cosine of x plus 3? Oh my God. What? Huh? We did do one, but this is a better one. Okay. We did one when we were still doing the table. Let's do this one. Okay, so what's the amplitude? Just one. Is there a change to the period? No, so we're going to go from 0, 1, 2, 3, 4 to 2 pi, pi, pi over 2, 3 pi over 2. Okay, there is a vertical shift upward 3 units. So 1, 2, 3, I'm going to go to 4. So here is 3. This is the new axis of oscillation. Okay, so this is 2 and this is 4. All right, guys. Okay, cosine. Does it start on or away? Away. So now we have a reflection. So are we going to start at the maximum or at the minimum? The minimum right here. Then we go to the axis, maximum, to the axis, minimum. And boom. Okay? There we have it. How beautiful is this though? Right? Come on. This is amazing. So this is where we're actually going to stop today. Your homework is just a worksheet of graphing these. Now, I know it would be a lot easier if I had like the grid lines in the background. I purposely didn't do that. You'll see why when we start doing like some of the other stuff, because things get a little, fuzzy. Next year, when you're so comfortable with this, like you'll change things up a little bit, okay? Like the curriculum is different. So, oh my God, how fun is this? Okay, so let's do the worksheet.